So, good evening everyone. So before we start, my topic is all about radioactive phenomenon in general. So, searching ko lang. Um, what does it mean by radioactive phenomenon? So, radioactivity is the phenomenon of the spontaneous miscellaneous unstable atomic nuclei to atomic nuclei to form more energetic stable atomic nuclei. So, so ibig sabihin natin sa radioactively yan, o sa ano natin, is more on, pag natin is more on radiation, kung nakakasama ba si radiation sa kapaligiran natin, or nakakatulong nga ba, or kung ano yung iba't ibang uri or types ng radioactivity. So, kailangan naman natin si Marie Curie. So, sino nga ba si Marie Curie? So, si Marie Curie is born by November 7, 1887, and he died on July 4, 1934. So, ano ang kinamatay ni Marie Curie? So, kinamatay niya is bone marrow failure, possible by Meydous plastic syndrome or plastic anemia. So, ibig sabihin, most commonly exposure to radiation yung pinamatay ni Marie Curie. Siyempre, ano ba pinag-aralan niya, diba? It's more on radiation. So, based din sa based on my research, merong invented si Marie Curie na radium and polonium na kung saan na may malaking tulong sa medicine. Ayun nga yung mga, na kung saan, ito nga yung tumutulong sa wait lang ha, lanin ko lang, ito yung best contribution yun na kung saan nakaka-detect ng cancer. So, dahil nga sinagawa ni Marie Curie, kung tama ako, based on my research yun or sa napanood ko yata, na ayun yung nagawa niya na most popular yung nagawa niya na nakatulong ng malaki sa medicine. Ito example niya siguro is X-ray. I'm not sure pero based on my research lang. Or based on my opinion na lang siguro para sure tayo. So, ayun nga. So, ito nga yung mga example ng radioactive phenomenon, X-ray machine, bag, ultraviolet from the sunlight, kaya nga linalabas ng radiation yan, visible light from the candle, yung ilaw ng kanila o yung apoy. So, maraming example ng radioactive phenomenon, hindi lang siguro sila. So, meron tayong 3 types, hindi sa 4 types, 3 types lang siya. The alpha particle, the beta particle, and the electromagnetic radiation. So, pag sinabi natin alpha particle, so this is the picture of alpha particle. So, alpha particle is consists of 2 protons and 2 neutrons. Nakita natin siya, di ba? Ito yung pinaka-heaviest type of radiation, the alpha particle. So, siyempre natin yung material na ginamit sa kanya is 2 protons and 2 neutrons, di ba? So, like an Earth, the uranium and the thorium, the emit of alpha particle. So, check ko sa inyo mamaya kung ano pa yung nagagawa ni alpha particle. Next one is the beta particle. There's the beta particle siguro, the best example ay the one of the fastest electron. The beta particle. And siyempre, tinatawag din siyang beta ray or beta radiation. So, siguro, best example ko siguro dito, yung kuryente. Yes, the electricity. So, the next one is, sikat na si electromagnetic radiation. So, madaling salita, siguro, example lang siguro na electromagnetic radiation. So, electromagnetic radiation is the best example is the X-ray. Kung saan, hindi ko siya na-explain eh. So, break mo tayo sa alpha particle. So, si alpha particle, siguro kaya lang humarang sa kanya is yung plastic or paper. So, bakit? Siyempre, sa alpha particle is consists of 2 protons. At yung pinaka-heaviest type of radiation sa lahat ng particle. Kaya hanggang kay plastic or kay paper lang siya. Mamaya sa video na mapanoorin nyo, mas maintindihan nyo kung bakit hanggang doon siya. Next one is the beta particle. Diba, gaya nga ng kuryente. Diba, hanggang saan lang gusto yan. Plastic, wood, diba? The best of conductor of the electricity. One of the example is the beta particle. Parang gawin lang si beta particle. So, So, the next one is electromagnetic radiation. So, siyempre sa electromagnetic radiation is kaya niyang tumagos sa katawan ng tao. Hindi siya multo parang yung radiation niya is kayang tumagos. Siyempre, meron din harmful na electromagnetic radiation na nakakasama sa kalusugan ng tao at pwede pa itong ikamatay. Siyempre, ito nga yung nagawa na malaking contribution ni Marie Curie is yung X-ray or yung gamma rays yata. At ito yata yung ano niya, based on my research na, based on my opinion. So, search naman dito. So, ayun nga, medyo yung iba yata itong PowerPoint ko. So, yun nga, diba? Si Alpha Particle hanggang kay Faker lang, si Beta hanggang kay ikaw niya Hunt lang. Tama rin, tabis-tabis talaga siya, no? Si Newton, nakapansin niyo, diba si Newton, yung diretso? Bakit kaya? Very good kasi, wala na naman siya any particle na kung saan na merong lang or harang sa tagusan niya. Hindi pa tayo tapos. So, I have a video. So, naka-search din naman siya. So, panoodin mo natin yung video na hinanda.
Our brain's response to the word radioactivity usually takes us into the realm of superheroes or into some dark, reimagined, post-apocalyptic world after a nuclear fallout.
Yan, di ba? Pag sinabi natin, wag naisip natin minsan radioactivity is more powerful. Or minsan iisip din natin na parang apocalypse or parang pag binagsakan ng radiation is maubos lahat ng tao sa mundo. Isip niyo ba yung naisip ko? Yak lang.
There is rarely a middle ground. However, 120 years ago, the world had a completely different perception of radioactivity.
Yeah, sa patuloy na pag-aaral ng radioactivity, so nag-iiba-iba na yung perception natin about the radiation, di ba? So, iba yung sabi niya. Nakakabuti yung radiation, iba naman is sabi, nakakasama yung radiation.
In fact, it was considered to be a miraculous reservoir of health and vitality. From toothpaste and watch dials to water and butter, radioactivity was everywhere.
So, yun nga. Si radioactivity is nasa paligid na lang natin. Nasa toothpaste, nasa water, or even man sa mga sa katawan natin. Ang minsan sa ginagamit nating gadget. Gadget is more of radiation lalo na yung cellphone.
So, what happened? How is this marvelous discovery, which was considered one of humankind's greatest achievements, turned into something that scares countless people across the globe? Well, let's start with the basics. Everything we see around us is composed of elements with stable atoms. The subatomic component responsible for maintaining the stability of an atom is called the nucleus. Now, imagine that you're about to sneeze, but it hasn't quite come out yet. How does that feel? It might be strange to describe, but that's exactly what certain atoms experience all the time.
Yun nga, di ba? Kapag hahating tayo, parang hindi natin alam kung ano gagawin natin, di ba? So, halo-halo. Joke lang. So,
urge to expel the excess and regain stability.
So, yun, bigla natin marirelease na lang. So, extend kami video.
Inside an atom's nucleus, there are positively charged protons and neutral neutrons. These nucleons are held together by a glue called the strong nuclear force. This strong force cancels out the repulsive electrostatic force of like-charged protons and keeps the nucleus stable. The nuclear force has a short range of action and is dependent on the ratio of neutrons and protons present in a nucleus. However, we see that the balance between the forces starts to waver in a nucleus where the number of neutrons exceeds the number of protons. A nucleus that exceeds the threshold number of neutrons and protons that the strong nuclear force can hold together comfortably will become more unstable. More specifically, these scenarios give rise to unstable isotopes of elements.
So, yun nga.
More specifically,
the scenario with the rest unstable is called the isotope.
These scenarios give rise to unstable isotopes of elements. Just as your body, through a series of expansions and contractions, expels a substance with a sneeze, similarly, the unstable isotopes of elements fling out different particles or forms of energy to restore balance between the forces in their nucleus. During this process of attaining stability, they change into a new nucleus. It is exactly this property, namely turning into something new to attain stability, that we call radioactivity. The process by which it transforms is called radioactive decay.
So, ulitin ulit natin. Pag sinabing
The process by
radioactivity, wait lang,
nucleus.
ulit natin na.
It is exactly this
Nawala
property,
rin ako eh.
namely turning into something new to attain stability, that we call radioactivity. The process by which it transforms is called radioactive decay. A nucleus can undergo nuclear or radioactive decay through the emission of alpha, beta, or gamma radiation.
So, yung dinuskas natin kanina na si alpha, beta, and gamma. So, pakinggan rin mabuti.
And some
Explain niya kung paano, kung bakit hanggang saan lang si alpha, kung ano lang hangganan ni beta, at kung ano hangganan ni gamma.
sometimes a combination of all three. The alpha particles are relatively heavy. They can travel only a few centimeters in the air and can be easily stopped by a sheet of paper or plastic.
So, yun nga, di ba, based sa paliwanag ko kanina, is more, dahil ng, ulit nga, kasi nga, kaya hanggang plastic na si alpha, beta particle, kasi it composed of na heavier particle na kung saan nandun si proton, or si positive charge.
Beta particles have higher energy and more penetrating power than alpha particles, but are less ionizing in nature. They can travel through the air, but can be stopped by a thin sheet of metal or even protective clothing. Finally, the most energetic and fatal form of radioactive decay is gamma rays. Yes, these are the type that supposedly turned Bruce Banner into the Hulk. This is a form of high-energy light emitted by a nucleus that is left at a higher energy state after an alpha and beta decay process, but must still return to a more stable, lower energy state. A nucleus can undergo all of these decays spontaneously and transform into a stable form within seconds, years, or even centuries. This rate of decay is decided by what we refer to as the half-life of the radioactive substance, which measures the time it takes for a given amount of the substance to become reduced by half as a consequence of decay. One cannot have a discussion regarding radioactivity without a mention of the famous scientist Marie Curie. Her lead-sealed radioactive laboratory, notebooks, cookbooks, and furniture contaminated by radium are a testimony to her contributions in the field. She is also the only person to win the Nobel Prize in both physics and chemistry.
Yun, wait, wait lang, may ad. Sensya na, may ad. So,
The discovery of radioactive
So, yan nga, di ba? Dagdag ko lang, si Marie Curie lang naman yung nanalo ng Nobel Prize in both physics and chemistry.
activity and radioactive elements came through Marie and Pierre Curie, along with Henri Becquerel in the early 1900s, opening up the gates to a completely new field of atomic physics. That eventually led to the discovery of different components of atoms and nuclear energy. For example, radioactive elements like uranium-235 and plutonium-239, when bombarded with neutrons, release an enormous amount of energy. Believe it or not, just 1 kilogram of uranium-235 can produce almost 24 million kilowatt-hours of power through nuclear fission. In comparison, 1 kilogram of coal can only produce 8 kilowatt-hours of energy. This is why it has been said that nuclear energy can power entire cities for decades. Needless to say, the sheer power and potential of carefully handled radioactivity and nuclear energy is immense. But, as is true with all great things, radioactivity also comes with some risks. Radiation as a whole isn't dangerous. Light bouncing off a reflective surface, the microwaves heating our food, or the signals received by our mobile phones are all different forms of radiation. However, there is one kind of radiation that is particularly harmful to all biological forms: ionizing or nuclear radiation.
So, ito lang naman yung nakakasama or nakaka-harmful sa isang tao, yung ionizing radiation. So, papansin natin, hindi siya parang pag tumugot siya sa katawan mo or malanghap mo siya, it's either na mamatay ka or magkasakit ka. Total naman ang individual.
Radiation. A radioactive material during its decay process emits ionizing radiation, and when a living being is exposed to such high-energy radiation, it doesn't make someone radioactive, but rather a likely victim of radiation poisoning. Radiation poisoning from nuclear radiation can easily damage the molecular structure of DNA and harm living cells. A heavy or prolonged dose can prove lethal, as these rays are carcinogenic. What happened at the Chernobyl?
So, wait lang. So, dagdag ko yun, di ba, sa X-ray, di ba? Kaya, yung X-ray is once lang sa isang taon. Or hindi siya sa isang taon. So, once lang siya ginagamit sa katawan mo. So, kung nagamit mo sa X-ray sa katawan mo, is no more that kasi nakakasama na siya sa buto. Pwede siyang, alam ko, pwede siyang makadurog ng buto eh. Kung pag laging ginagamit sa X-ray sa loob ng katawan natin. Or hihina yung mga cells natin sa katawan. Ayun lang yung pinaka-harmful kay X-ray.
Reactor decades ago has left mankind shaken to this day. One incident of a reactor meltdown and 4 square miles of land are rendered uninhabitable for generations, not to mention the thousands of lives exposed to the indelible effects of radiation poisoning. The remains of the reactor sit inside a containment structure made of thick steel walls. Cleanup protocols will be continued until 2065. The Fukushima Daiichi reactor that was hit by a tsunami in 2011 forced the evacuation of thousands in a 20-kilometer radius of the incident. The authorities are still cleaning up its surroundings, including removing and disposing of the topsoil in the affected region. Although it may seem that the word radioactive has a negative connotation, surprisingly, radioactivity is not always harmful. There is a saying in toxicology that the dose makes the poison. It's true that when a person is exposed to unregulated amounts of radioactive material, it can cause severe genetic mutations and cancer. However, when regulated, it can also cure cancer. Radioactive iodine is used in radiation therapy to treat cancer and for imaging in the thyroid gland. Radioactive technetium is used for the detection of heart, bone, and other organ defects.
So, balik lang ulit natin kanina, di ba? Sinabi natin kanina is nakakasama si iodine radioactive. So, sa base sa pag-aaral ng mga scientists is nagawa nilang parang gawing medicine na lang. Hindi na makasama si iodine kung saan
Radiation therapy to treat cancer.
Ay naging therapy na siya para sa treat ng cancer. One of the contribute of Marie Curie.
And for imaging in the thyroid gland. Radioactive technetium is used for the detection of heart, bone, and other organs.
Ito na example ni X-ray. See? Radioactive technetium.
Defects. Radioactive C14 carbon is used in carbon dating, which helps us determine the age of things. In some countries, fresh produce is lightly irradiated before packaging to kill off the germs on the surface of fruits and vegetables. A tiny amount of americium kills off the germs.
Dito, sinat ko to eh. Almost hindi siya totoo. Hindi ko lang alam bakit sinabi sa video na to. Kasi sa pagkaya is negative radiation is almost harmful talaga sa loob ng katawan natin. So, hindi ko alam sino yung mali, kung yung sa research ko ba o yung sa video. So, search nila lang din.
On the surface of fruits and vegetables. A tiny amount of americium-241 is used in smoke alarms that help save thousands of lives every year. Quite simply, radioactivity is everywhere. But hypothetically, if you end up backpacking to an unknown land and the Geiger counter in your bag starts crackling, the best thing you can do is run.
So yun lamang po. So before we proceed to our last, I have a parang i-realize ko sa inyo. So sa tingin niyo ba, si radiation ba, this is a good or bad? So malaman ko yung sagot dito. So siguro magkakaroon tayo ng live session na ito kay Ma'am sa Lunes. Kung mauna si Ma'am Marjorie ako, kung ako mauna, so let's answer this question. So have a good night. Have a nice day. Thank you. Peace.